All right, let's get started. So let's go over this paper. I found some of the questions to be kind of interesting, so I thought we could discuss it. But we go through all of the questions so that, there's like in case there's something that you have a doubt about, we can clarify that. You guys can give me the answers of whatever you know, and we can keep walking our way through it. Okay, first question.
Option A.
Option A, why?
Wait.
Yeah, take a second.
Ma'am, it can be D as well, right?
Why B?
D, not B.
Why
I was
D?
gonna say D.
Why D? Why is it a neutralization? When is something considered to be a neutralization reaction? When it is an acid plus a base. Okay, now more than acid plus base, it has to give you a salt and water. Now we don't get water formation in this reaction, right? Because this reaction is just NH3 plus HCl giving you NH4Cl. So it's only a combination reaction because the combination reaction is very specifically defined as a reaction where you have two compounds or elements combining to form one product. The reason it is not a neutralization reaction, there's two things. If you remember, neutralization reactions actually get classified under the category of double decomposition. Correct? So that means there has to be a transfer of either, an exchange of either anions or cations, which means you need to get two products at the end of it. So if it was NH4 OH plus HCl, then your OH will transfer here, your chlorine will transfer here, and you will get NH4Cl plus H2O. So there's been an exchange of the anions or the exchange of the cations that's seen. Correct? So your double decomposition is when you have a transfer of both anion or cation, either both the anions or both the cations. And the double decomposition is further classified as precipitation or neutralization. When do we classify it as precipitation? When we are forming a compound that is an insoluble salt. So it precipitates out as a solid. When do we classify a double decomposition as a neutralization reaction? When we get salt and water. Okay, so that means there is the requirement for two products to be formed at the end of neutralization, where one has to be a salt and one has to be a water. That's why it cannot be a neutralization reaction. Is that clear? Okay, the first one is right. Yeah, why is it? So that's why it's a combination reaction. Why is it an acidic salt? Because when you put the ammonium chloride into solution, right? When you put the ammonium chloride into solution, it is literally going to give this reaction, correct? It's going to give you this backward reaction. It's going to form HCl and ammonium hydroxide. Now, between HCl and ammonium hydroxide, this is a weak base and this is a strong acid. So if it is a strong acid, it will dissociate in solution to form a lot of H plus ions. It will undergo complete dissociation. So because it is forming undergoing complete dissociation and forming H plus ions in solution, the pH of it will move towards the acidic range. Is that clear? Okay, that's the first one. Okay, second one.
Option C.
Okay, option C is right. Yes. Okay, so you have Fe2O3 plus Al is the correct answer for that. Perfect. Okay. All right. Let's move on. What about what about question 3?
Option B.
Option B. Yes. So in this, if you get a question like this and you're confused, pick one to focus on. So for example, for me, I always remember that marble is calcium carbonate, and I was fortunate that that's the only option where calcium carbonate is the third one, right? So yes, it is possible to get confused. So pick one and try to use that as your elimination process. Okay, let's look at question 4.
Is it option A, 1 and 2?
It is going to be option A because sodium and potassium is found in both soaps and detergents also have sodium and sulfonate in them. Okay, sulfonate is a huge part of your detergents of the chemical properties of detergents. So that's why it's going to be A. Yeah, awesome. Okay, 5.
Brown colored compound with pungent.
Yeah, this is what even I would say. Okay, yeah. All right. So this is because we are looking at FeSO4 dot 7H2O breaking down into FeSO4 plus 7H2O, and the FeSO4 further degrading into Fe2O3 plus SO2 plus SO3. Okay, this Fe2O3 is the brown colored compound, and your sulfur dioxide is your pungent smelling gas. Actually, both of these are pungent smelling gases. Okay, the reason why it is not the first one or the second one is because, yes, removal of water is important, but that is not a chemical change. It is very much like a physical change only, because when you add that water back into the anhydrous ferrous sulfate, it will go back to form the hydrated ferrous sulfate very easily. Okay, so that's why it is not A, B, and obviously it's not going to be C, because the final product with the pungent smelling gases is a salt that is brown in colored. Okay, awesome. Next one.
Green.
Green is right. Yes. Okay. Analysis or why that is your answer?
Because both of them, they're strong acid and strong base, so it will be neutral. So green.
Yes. Perfect. Okay. Next.
C.
Why C?
C.
Why C? Why C?
Because 3CO is getting oxidized.
To carbon dioxide. Perfect.
Yeah.
So in everything else, you have the removal of oxygen occurring. In this is going carbon dioxide to carbon monoxide. This is going from FeO to Fe. This is going from CuO to Cu. Right. So because of this removal of oxygen, none of these are being oxidized. They're all being reduced. Yeah. Okay. Brilliant. Let's go to the next one. There was one here, right? There's an assertion reasoning. Yeah. Any answer for the assertion reasoning?
Is it B?
It would be B, because both of them are right. But just because the reaction is exothermic, it doesn't necessarily have to mean that it's going to be a neutralization reaction. Or let's put it this way, just because the reaction is exothermic doesn't mean that it is neutralization occurring. Exothermic would be an effect of what happens because of neutralization. Okay, let's look at question 21. Would you guys have attempted this if it had come in your paper?
The anode should be kept on the left side and the cathode should be kept on the right side.
Yes, perfect. Anode here, cathode here. Can you tell me why?
Because of the positive and negative charge. No.
Where is the positive negative charge here? Based on what did you tell me that anode and cathode are in the wrong places?
Well, because in my exams I have been given these diagrams and the cathode was always on the right side, so I just thought about it.
No, that's okay, that worked here, but that's not necessarily the answer. Look at the products. Oxygen is being given out over here and hydrogen is being given out here. Oxygen is a product of the anode when you have the anode reaction, and cathode is a product of the reaction occurring at the hydrogen is a product of the cathode reaction. Because if you remember, if water is splitting up into H plus and OH minus, this is going to release as O2 and this is going to liberate as H2. Okay, so that's why this is your anode product and this is your cathode product. Okay, the positive charge will go towards, this is a cation because it goes to the cathode. So because this moves towards the cathode, that's where hydrogen gas will be liberated. This is an anion, so it moves towards the anode, and therefore that's where the oxygen would be liberated. Okay, so the reasoning behind it should be based upon the products that we are seeing as oxygen and hydrogen. Okay, all right, next one. I mean, your logic worked. Your logic worked. You were very lucky it worked. Okay, next one. Do you know how to test for these gases?
Ma'am, for O2, the candle would burn brightly, and for H2, it would go off with a pop sound.
Brilliant. Perfect. Okay, next one. I think these are straightforward. You guys are okay to write equations and balance them. Are you, Druvika, are you still having any issues with that part?
No, I did this.
It's better? Okay,
Yeah.
all right.
Yeah.
Yeah. Anybody else want me to go over these equations? Just write it out very
No.
quickly anyway. So Na2SO4 plus BaCl2 giving you NaCl plus BaSO4. So naturally balancing has to be done. So 2 in front of NaCl, AgCl giving you Ag plus Cl2, 2 and 2, and you write about here about decomposition. Okay, let's go on. Yes, let's talk about this question. The melting point of calcium oxide. I saw that I think another paper of Niveda's was also similar to this. Some question like this. Was it Niveda's or was it Druvika's? I don't remember. Someone's paper had this, but let's talk about this.
Can I answer?
Yes, please.
Chlorine is a halogen, so it has a negative charge, and
Okay.
it is electronegative. So if it
Okay.
is heated, then it will break the bond and take its
Okay.
electrons quicker
Okay.
than calcium oxide.
Okay, that's one interesting explanation. Anyone want to give me something else? Any other things that you can think of? Okay, I want you to think in also in terms of what is the structure looking like. So we know that when we look at calcium oxide, right? Calcium is donating 2 electrons to the same compound, I mean to the same atom, right? Which means this is almost like a double bond type because it is an interaction between only the two molecules, right, with an exchange of 2 electrons to the same thing. So this gives rise to a stronger ionic bonding because of the higher charges that are involved. This is a 2 plus and this is a 2 minus. Okay, now now while chlorine is electronegative, oxygen is also electronegative. Yeah, it's not as strong as chlorine is, but the electronegativity, so the concept of electronegativity comes into picture 99% only when we're talking about a covalent bonding, because electronegativity is defined as in a shared pair of electrons, which atom is able to pull the or attract the pair of electrons towards itself is what we define as electronegativity. Okay, so when we are not talking about a covalent bond, see, because magnesium chloride is also an ionic bond, right? The difference is that it is donating 1 electron to each of the Cl atoms. Okay, so that means that while Mg is 2 plus, your chlorines are only 1 minus. Okay, so it is easier to break it. So I would not award marks for writing about electronegativity here, because while chlorine is definitely electronegative, its electronegative character is highlighted only when it is in a covalent bond. So, for example, if the question was, let's say, something related to HCl or rather, let's say the question was something about okay, fine. Methane and CH3Cl. In here, between these two, the bond would be easier to break for CH3Cl because chlorine is electronegative and pulls the shared pair of electrons towards itself. But there's no, here all of the shared pairs of electrons are shared very equally between the carbon atoms. Okay, so here electronegativity is a perfectly appropriate explanation. When we're talking in terms of ionic bonding, the concepts that come in association with an ionic bonding would be hydration enthalpy, lattice enthalpy, high intermolecular, high or stronger ionic bonding. Those are the concepts that will come into picture. Okay, so I don't think that electronegativity would necessarily be awarded the marks, even though you're on the right track of the concept. It's not a concept that's associated with ionic bonding necessarily. Is that idea clear? Yeah? No?
Yes, ma'am.
Yeah? Okay. So I'm not saying that electronegativity is wrong. I'm just saying that while fluoride is definitely more electronegative than oxygen and definitely contributes to the breaking of the bond faster, it's not necessarily a concept that is associated with ionic bonding. It is associated with covalent bonding. So electronegativity would play a lesser role here than, let's say, lattice enthalpy or ionic. The ionic bonding itself is stronger in calcium oxide versus magnesium chloride because two pairs of electrons are being two electrons are being transferred, which creates a stronger ionic force between Ca2 plus and O2 minus, versus where we're only transferring one electron to each of the chlorines. Yeah. Okay. All right. Everyone's okay to draw the electron dot structure of calcium oxide. So I need to
Yes.
draw it in. Yeah, everything's fine. Okay, let's talk about the next question. Niveda, did you get the same question in your pre-board? I feel like this question is so
The third one?
This one, 28th one. This one in general. No?
I got this from my Sahodaya, yeah, not for any
This is the
other.
Sahodaya. Only for the this is the Sahodaya paper. You didn't get it in your exam. Okay.
Not
Maybe it was
this.
someone else's paper. Okay. All right.
So calcium auxiliary chloride, CaOCl2,
Yes, which is also called as
a bleaching
bleaching
powder.
powder. Yeah, perfect.
Yeah.
Bleaching powder. Perfect. Yeah, okay. Are you familiar with the equation for its formation?
Yes.
Yes.
CaOH whole twice plus
Okay.
Cl2 equals to CaO Cl2 whole twice plus H2O.
Awesome. One more usage of bleaching powder.
Disinfectant.
Disinfectant, yes. Perfect. Perfect. Okay. And finally, the role in the chemical industry.
It's
Used as a
an
bleaching
oxide.
agent.
Yeah. Okay. All right. You guys clearly have this under control. All right. Let's move on to the next question. Let's do this. Everyone's favorite organic. Let's talk about it.
It's alcohol, ethyl,
Very
Y
good.
is,
Ethyl
and
alcohol is right.
X is alcohol, and Y is carboxylic acid, that is ethanoic acid.
Perfect. Okay. So when you're trying to look at the member, so I'll tell you in general, I've noticed that this question mention what is the second member or third member of a homologous series. The more number of mistakes happen when we're talking about alkenes and alkynes. Now, the only thing I want you to remember when we're talking about alkenes and alkynes is that the very first member in an alkene and alkyne is a two-member chain. So when they say third member of the series, you're starting off with two. So 2 is the first member, 3 is the second member, 4 is the third member, right? But for all the other compounds, right? Alkanes, alcohols, carboxylic acids, aldehydes, not ketones. I'll come to ketones in a bit, not ketones. For all the rest, right? It is, you start off with one carbon. So you have methane for this, you have methanol for acid, and you have methanoic acid. So, methanoic acid for acid, methanol for alcohols, and methane for alkanes. So here, the second member will be with two carbons. Now, ketone is the biggest exception because your very first member in a ketone is directly with three carbons. So a second member or a third member in this would be CH3, CH2, CO, CH3, or CH3, CH2, O, CH2, CH3. Okay, or even CH3, CH2, CH2O, CH3. Basically, you will increase it from here to here by adding one CH2 group. That is how you build on the homologous series. You add a CH2 to every next step to get the next whatever is the next compound for it. Okay, so again, I've not seen them ask you about ketones a lot, but there have been multiple papers I've seen across multiple schools where alkenes and alkynes get asked all the time. And it's mostly the second or the third member that they ask for an alkene and an alkyne. For an alkene or an alkyne, you start off with two carbons. This is your first family member. Okay, if this is going to be your first family member, the second family member, you add an extra carbon to it. That's it. Okay, add an extra carbon to it. All right. Okay, can we talk about the second part of this question? How do these two react? And do you guys know the chemical equation for this?
Yeah, it forms an ester.
It
So
forms an
C2,
ester, correct? Okay.
yeah, C2H5OH plus CH3COOH gives CH3COO C2H5 plus H2O.
Perfect. Yeah. Okay. What is the, so this is our equation. And this is your pleasant smelling compound. All right. Do you know the IUPAC name for this?
Ethyl acetate.
No, ethyl ethanoate. Ethyl ethanoate. I think someone is going to say that. Who is going to say that? Okay, so ethyl ethanoate. Okay, that would be the IUPAC name for this compound. Ethyl acetate is the common name for it. All right. Okay, this is fine. Role of concentrated sulfuric acid. Yeah.
Is it a dehydrating agent?
It's just a catalyst over here. Okay, you can talk about it as a dehydrating agent as well. Yeah, you can call it a dehydrating agent as well because it is removing water from the process. Go for it. Yeah. Okay. Any idea what is an important precaution to be taken?
The water or the ester formed should be removed as fast as it is formed.
Okay. Why?
Because the reaction is reversible, so to shift the equilibrium in the forward direction.
Awesome. Awesome. That's awesome. Yes. Okay.
Ma'am,
Yes.
can we
Anything
say,
else?
since both the compounds are volatile, it should be done in a water bath?
Yeah, ideally you would want to keep the temperatures as low because this is a slightly exothermic reaction as well. So you would want to do it in a place where you know, you don't allow the temperature to go too high. So that would also be a precaution that you would want to take. Definitely. Okay. One use of Y, which is basically ethanoic acid.
Preservative.
Yeah. Yeah. Basically it's vinegar. So you can use vinegar for multiple purposes, from cooking to preservation to making salads, whatever way you want to talk about it, but it's basically vinegar. So yeah. Okay, let's talk about the next one. Let's talk about this set.
So A is C2H5OH, which is ethanol,
Excellent.
and B is C2H6.
No, the first is right. It says is the incomplete formula to which an atom of hydrogen, if it is added, you get A, but if the atom of hydrogen is removed, you will get a compound B. It's an interesting question. So let's try it. So basically what they're saying is, if I already have 2 carbons, 5 hydrogens and an oxygen. Okay. Now, if I was to add a hydrogen to this, I get an alcohol. Yeah, perfect. But if I remove a hydrogen, then what would ideally happen is there would be a double bond formed between carbon and oxygen, because carbon needs to complete its tetravalency, correct? So to complete its tetravalency, carbon will double bond with oxygen, and these are the hydrogens that are left behind. Now, what compound do you see here?
Ethanol.
Excellent. Yes, this is ethanol. Did you follow what I just did over here? Do you want me? Does anyone want me to redraw it? It's fine.
Yeah.
Okay. Yeah. So this is your ethanol and this is your alcohol. So that's it. We have, once you have this, everything else is fine. We have the structural formula for A and B. When they say structural formula for A, please make sure you expand it, 2 carbons, and you draw the hydrogens. This is the structural formula. This is called molecular formula. And if you write CH3, CH2OH, this is called as the condensed formula. Okay, so when they are specifically asking for the structural formula, ensure you expand and show the hydrogens and the, like, you show all the hydrogens, the bonding between the carbon and the double bond between carbon and oxygen, all of that has to be shown. Okay. All right. So I think IUPAC names we've already discussed. Functional groups. You guys are comfortable identifying the functional groups. Yeah. So ethanol will have an alcoholic functional group. Ethanal will have an aldehyde as the functional group. Okay, next. With the conditions, write the equation for the oxidation of compound A in the presence of an oxidizing agent. Okay.
Okay, so it would become CH3COOH, and the oxidizing agent can be potassium dichromate or potassium permanganate.
Under what conditions?
Under
This is with
heat,
conditions. You're talking about alkaline or acidic?
alkaline
Potassium permanganate or acidified potassium dichromate. Okay, so when they're saying with conditions, that has to be mentioned very, very clearly. Awesome. Okay, 2 uses of A, 2 uses of ethanol.
ingredient for like alcoholic drinks.
Okay. It's also used as an antimicrobial agent. I don't know if you, or antiseptic agent. I'm not sure if you people have learned of that. You can also talk about it being utilized for the formation of esters, because esters play a huge role in the perfume industry. So it's also utilized for formation of esters. Okay. All right, let's do this last. I think this is the last question, right? Yeah, let's do this last question. Any questions on this part of organic? Is there anything that you want me to go over in this chapter? You're all comfortable with the functional groups and all that is fine?
Yes, ma'am.
Okay, let's talk about this 37th question.
Ma'am, they're used as oxidizing agent.
Which is used as oxidizing agents?
Both of them.
Both of them cannot, both of them in the same place cannot be used as oxidizing agents, right? 1 second. Let me just finish reading the entire thing. Sulfur is, what is the role of sulfur dioxide and nitric oxide? Okay. Sulfur is burnt to form sulfur dioxide. Nitric oxide is definitely used as an oxidizing agent. Absolutely correct. Because we're using that to convert sulfur to sulfuric acid. Okay. Where are we using the sulfuric acid? Yeah, okay. Sulfuric acid will also be a oxidizing agent. Okay. You guys comfortable with this equation?
Yeah.
This is fine. I think they've given you,
2Ng plus SO2 equals to 2MgO plus S.
Yeah, perfect. Okay. And this is interesting. Yeah.
SO2 is acidic because it combines with water to produce sulfuric acid.
Brilliant.
The blue litmus test becomes crimson in its acidic aqueous solution. SO2
Okay.
is therefore as categorized as sulfuric dioxide. So the blue litmus test could be
Used to identify the acidic nature of sulfur dioxide.
Yeah.
Perfect. And for magnesium oxide? Exact same thing. Drop magnesium oxide into water, it becomes magnesium hydroxide, which you can then test with red litmus and it'll turn red litmus blue because magnesium hydroxide is basic in nature, which will then in turn tell you that magnesium oxide is also basic in nature. Exactly the same, just okay, or exactly the opposite. Yeah. Okay, I found this paper to be quite interesting. I think it was definitely some very well thought out questions that you needed to sit and slightly analyze.